we're going to discuss applications of systems of equations. 2 equations in 2 unknowns, or 3 equations in 3 unknowns, or any number of equations in the same number of unknowns. We're going to do some examples on motion. One of the applications of these is motion. We also have investments, mixing, and other applications. But in this video, we're going to do motion only. The others, investments, mixing, and other applications, I want to do them in a different video. So for the motion, one of the most important formulas is this: distance equals speed multiplied by time, from which the speed equals distance divided by time. Or if we use the letter V for speed, V equals D over T. We're going to be using this formula. The jet stream is the motion of the air high up in the atmosphere, and the jet stream usually goes from west to east, just like I have shown in here, from west to east. For example, from California to Michigan, or to Washington, or from the USA to Africa or to Europe, etc. When an airplane is traveling in a jet stream, when it's moving this way with the stream, it's not the same thing as when it's moving against the stream. So when the airplane is moving from west and going in the direction east, the jet stream also goes from west to east. So therefore, the net speed of the airplane is the sum of the 2 speeds. For example, suppose the plane is going at 600 kilometers per hour. Plane. And the wind is going at 100 kilometers per hour. The net speed of the plane going this way is the sum of these 2 speeds, which is 600 plus 100, which is 700 kilometers per hour. Okay. If a plane is coming back this way at 600 kilometers per hour, and the wind is this way, so the plane is going this way at 600, the wind is going this way at 100. In this case, the net speed is the difference of the 2, so it'll be 600 minus 100, which is 500 kilometers per hour. Okay. We have a choice. We can call the speed of the plane X and the speed of the wind Y, or we could call the speed of the plane P and the speed of the wind W. So let's call them P and W. Okay, when the plane and the wind are going both this way, plane, wind, the net speed is always P plus W. But when the plane is going this way and the wind is going this way, we'll make this a little bit longer. Plane, wind. Now the jet stream does not change directions. It always goes from west to east. The net speed is going to be P minus W. Okay, we're going to assume that the plane does not go at an angle, because if it does, that's going to involve trigonometry, and that's a different topic. Let's do this example. It takes an airplane 8 hours with the wind to travel a distance of 7,200 kilometers between Detroit and West Africa, and the flight back against the wind takes 10 hours. They want to know what was the speed of the plane and what's the speed of the wind. Okay, this is what we're going to do. We're going to call the speed of the plane P. So plane is P, and then wind is W. Okay, with the wind, that's also called a tailwind. Against the wind is called a headwind. So this is a tailwind, wind, and this one here is a headwind. That means the wind is coming against the head of the plane. Okay, so we need to find the 2 speeds. Okay, the distance is 7,200 kilometers, so speed equals distance divided by time. So you divide 7,200 kilometers by the time. And the time, it's 8 hours. Okay. This is 900 kilometers per hour. Then we're going to divide 7,200 by 10 hours on the flight back. So d over t equals 7,200 divided by 10, which is 720 kilometers per hour. Okay, now we need to set up our equations. Earlier we said that with the wind, that means the tailwind, the net speed is p plus w. Without against the wind, the net speed is p minus w. So p plus w, first equation is p plus w equals. Second equation is p minus w equals. Now with the wind, the speed was 900 kilometers per hour. Against the wind, the speed was 720. We got those. So now we have two equations in two unknowns. They're p and w, but they could have been x and y like we said earlier. This system can be solved by addition. We're going to add the two equations. Why? Because the plus w and minus w will cancel. So p plus p is 2p. And then these two cancel. Plus w minus w will cancel. Equals. Add these two numbers. So you end up with 1620. Divide both sides by 2. And that'll give you p equals 810. Now put this p equals 810 in any of these equations, and then that'll give you w. Let's put it in the first one. So p plus w, first one, equals 900. We know that this is 810, so put 810 here, plus w equals 900. Okay, this is a plus, so we're going to subtract 810. Subtract 810. That gives us w equals 90. The advantage of calling these letters P and W as opposed to X and Y is we know what they are. P stands for plane and W stands for 90. So the plane travels at 810 kilometers per hour. The wind travels at 90 kilometers per hour. And that completes the problem. We're going to do another problem. It takes an airplane 7 hours with the wind to travel a distance of 5,600 kilometers between Detroit and Dublin. The flight back against the wind takes 8 hours. What's the speed of the plane? What's the speed of the wind? So first we need to find the two net speeds. Okay, the net speeds are, okay, speed equals distance divided by time. So divide 5,600, that's a distance, over the time, which is 7 hours. And that'll give you 800. We'll put the units later. The next net speed is d over t, which is 5,600, divided by the other time that's given, which is 8 hours. And that's 700. Okay, one of these is the net speed when the plane is going with the wind. This is the net speed when the plane is going against the wind. Let us set up the equations. Okay, with the wind, the speed was p plus w. So p plus w equals 800. Against the wind, the speed is p minus w. P minus w is 700. We have two equations and two unknowns that can be solved by addition. Add these two equations. P plus p is 2p. W is cancelled. 800 plus 700 is 1500. Divide by 2. So that gives us p equals 750. Okay. Put this number in one of these equations, like the first one. P plus W equals 800. So put 750 in here. So 750 plus W equals 800. This is a plus, so subtract 750. And that'll give us W equals 50. So the plane travels at 750 kilometers per hour. The wind travels at 50 kilometers per hour. And this completes this problem. We can solve this problem also of a boat in water. Same thing. When the boat is going upstream and when it's going downstream, the boat goes at different net velocities. Okay, it takes about 3 hours to travel a distance of 120 kilometers when going downstream. That means in the same direction as the water. It takes about 4 hours to travel the same distance back upstream against the water. What's the speed of the boat? What's the speed of the water? This time, let us call the speed of the boat B, speed of the water W. So, the speed is distance over time. So you divide 120 by 3, that gives you 40. The speed in the other direction is distance over time, which is 120 over 4 hours. So that's 30 kilometers per hour. We'll put the units later. When the boat is going in the same direction as the water, the net speed is B plus W. That's downstream. B plus W equals 40. When the boat is going against the water, it's B minus W. That's upstream. And the net speed is 30. The system can be solved by addition. B plus B is 2B. W is cancelled. 40 plus 30 is 70. So divide by 2. And that gives you B equals 35. Put 35 back in one of these equations. Let's put it back in this equation. B plus W equals 40. So 35 plus what number equals 40? Well, the answer is subtract 35. So that gives you W equals 5. So we have boat and we have water. The boat was traveling at 35 kilometers per hour. But the water was traveling at 5 kilometers per hour. So sometimes the water helps it go faster, sometimes it slows it down. It depends on which way the stream is going, which way the boat is going. And this completes this application of motion.